Hey everybody, welcome to another Bill Sky the Assembly Guy video on assembly language. And what we're going to do today is another video on variables, this time for Windows. So let's just get right to it. Alright, what we have here is Visual Studio is up and running. I have a 64-bit application ready to go. And we're going to go ahead and start working on variables. Now, I did a little bit of this in a previous video on integer sizes. This is going to be a much more comprehensive one where we talk about strings and chars and floats and all that. So there's going to be a lot more to this video than just that one integer video. So let's take a look at some of this will be repeat, some of it will not. Right off the bat, you can see in the data section right here in our Windows 64-bit application, you can see that we've got a couple of strings. Now, what makes a string? A string, in this case, welcome message, is a set of bytes, so we define bytes, and in double quotes or single quotes, you define a string. Also, you notice this comma 00H, that means add a 0 at the end of that string. So add another byte with nothing but 0. That's called a null terminated string. So in just about every language on the planet, strings are always null terminated. It's kind of like the stop sign for the string. How far does the string go? Now, if you don't have that 0 there, what the program might think when you want to do something with a string is that it starts with hello world and the string continues with program ending have a nice day. So it really is important to zero terminate your strings, and they should have even, or you should have even learned that in C or C++ if you took those in school or if you've learned it on your own. So always zero terminate a string. So this is a set of bytes. It's almost like an array of chars beginning with HELLO and world. So that's a string. That's actually how a string is. Now let's jump into bytes, or let's jump into integers. So as the previous video on integer sizes, we're just going to go through this quickly. I'm going to call this a byte var. I'm going to define a byte with a value of 0FFH. Now, a byte is 2 nibbles. I have a third nibble there simply because whenever you have a hexadecimal value that begins with a letter, you must start it with a 0. So that's just for the assembler. I'm not trying to allocate 3 nibbles in a single byte, which can only hold 2, but I'm just doing that for the assembler. So that is a byte variable called byte var that has a value of FF in it. Now, what if I want to create a variable that doesn't have a value? So I can create a byte var2 define byte and put a question mark. Now in Windows, that's how you do it. You say question mark, you do not put it in the BSS section. You put question mark. So that's an uninitialized variable. Now something else you can do here in Windows that you can't do in Linux is you can use the byte macro. And the byte macro is exactly the same as the DB. So I can put a question mark there, or I can put a 12H, or I can put a decimal, whatever. Okay, so byte is the same as DB. Now you won't see me using this syntax very often because I like my assembly language programs to be as compatible with other operating systems as possible, and they all seem to use this DB, and only Windows uses the byte. All right, so that's a byte. Let's take a look at, let's put some comments in here. Again, I mentioned this in the Linux version of this video. Comments are so important. If you haven't watched the Linux video, I'll tell you the little story again. I was working for Martin Marietta in Florida. I was working on F16 night vision software, and I was doing it in assembly language. It was different than x86 assembly language back then. That was back in the mid 80s. And the problem is that I was working for like two and a half hours on this assembly language project. I got up to go to lunch. I came back. I had this roommate with me who kind of laughed as I came back. And I looked at my code and I had no freaking idea what I had done. I hadn't commented any of my code. I could not believe it. And my roommate, really great guy, my office mate, he started laughing. And I said, "What are you laughing about?" He said, "I saw you weren't writing any comments, but I thought it was better for you to learn the hard way." And it probably took me 2 hours of debugging my code, looking at what I had done, to get up to speed. So again, comments in assembler are so important. So I'm going to put some comments there. All right, so let's take a look at a word var. Define word 0FFFF. Or I could say word var 2, define word question mark. That defines 2 bytes, a word not initialized. Or I could say word var 3. Oops. Word var 3, and I could say word question mark or 1, 2, 3 or whatever. So you also have the option to say word on Windows. All right, let's say D word var 1, define double 0, 1, 2. Well, I don't need a 0 in front because I don't have I'm not going to have a letter. Here's my double word. I can say double word var 2, D word 0H, or I could say D word var 3, define double question mark. That's an uninitialized. Now in Linux, you would have to put that inside of the BSS section, but on Windows you don't. What I think is happening is, and I don't have any proof of this, so if anybody knows for sure, I think what is happening is this word actually moves that allocation to a BSS section on Windows because the processors are pretty much the same. Also, Windows, when you're debugging your code, Windows will display it in the debugger differently if you use these. You can do it manually, but it'll automatically display it in a different way. And I can say keyword var 1, define quad, whatever you want, keyword var 2, define quad question mark, or keyword var 3, keyword 4, 5, 5, 6, 7. So you can do it all those ways. Now I just created a bunch of stuff. I probably should have saved and built it more often, but let's just make sure we don't have any syntax errors, and we don't. Everything is great. So that's how you create bytes, words, double words, and quad words in Windows. Now, how do you create floating point? So that's the next thing we're going to do. So floating point values or variables. Now they're really not. You really shouldn't call them variables because you're not actually creating variables. What you're doing is you're asking for memory to be allocated for you, and the beginning of that memory is this name you're giving it. So it's not really a variable. You know, technically it is, but actually technically it's not. But you know, you can think of it that way. But you're actually just labeling memory, and that's why they call these labels. They don't call them variables. So floating point. So I'm going to create a floating point number, single precision, and on Windows you can say real 4, a 4-byte floating point, and I can give it a value. Another way I can do it is I can say define double 123.45, or you can even put a negative in front. Now, the difference between integer and floating point numbers in memory is huge. They're not going to look. The number in binary and floating point is not going to look anything like 123.45. It's using an IEEE standard for floating point conversion or floating point coding. We're going to talk more about that when we get into floating point. I'm going to save and build this, make sure I don't have any syntax errors in my code, and I don't. So a real 4 is actually 4 bytes. That's the same as a double. I could also say a float double precision is a real 8, and that can be another number. Now, what's the difference between single precision and double precision? Double precision means you're going to have much more accuracy in the fractional portion of your floating point number. So double, if you really need a lot of accuracy, like doing science and things like that, DP is probably the best, or double precision is probably the best. If you're just doing like 2 digits of fractional work, like for accounting or just your I don't know, your home budget, you really don't need the double precision because it is 8 bytes. So I can say a float dp2 define a quad minus 1 to 3.67. So a quad word is 8 bytes, or you can say real. Again, these Windows only syntax, this Windows only syntax is used mainly for the debugger. It does exactly the same thing as just normal size. And then the last one is the extended precision. So I'm going to say a float extended precision. I'm going to say real 10. And this is a 10 byte floating point. And your number can be pretty darn big. Or I could say a float extended precision 2, define 10, and I can do the same thing. And they don't have to be negative on these types here. I'm just putting them there to show you how you can have either one. And as usual, I always like to build it after I write a couple lines of code to make sure I didn't create something that broke my assemble. All right, so that is floating points. Now let's take a look at characters. Now we already talked a little bit about characters at the very beginning. We had some strings here, but let's go through this pretty quickly. So I can create a single char, define byte as the letter capital A, notice the single quotes, or I could say a char 2, oops, typed it in wrong. I could say byte with double quotes. I'm a little bit obsessive compulsive. I always like my things to line up. It makes it look nicer. So again, instead of dB, you could use byte. Instead of byte, you could use dB. You can use single quotes or you can use double quotes. It doesn't matter. Now, if you're going to be creating a char that you're not going to really be printing anywhere, you're not going to be displaying it to the user, you really don't need to have it zero terminated. As soon as you create any kind of a string that's going to be displayed to the user, you want to zero terminate it. So I'm going to call it my name, define byte, hello, my name is Bill. Now that for sure is going to be a string that I'm going to be sending off or displaying on the terminal. So you definitely want to have it zero terminated there. The other thing you could do is, and we already showed a little bit of this, but I like to show it again. You can create it using a byte, using the byte keyword. Okay, another thing you can do, you can create a carriage return at the end instead of 08. So I'm going 08. So I'm going to go ahead and, oops, what just happened there? So I'm going to go ahead and paste that. I'm going to call this my name 3. And instead of 0h, I can say 0ah, 0dh, and 0h. And what is that all about? Well, when you print a string on the screen, if you remember in C++, you can use the end L. So in C++, I can say end L, or I can say \n. That goes to the beginning of the next line. Okay, that's called the carriage return. And when you do that in C and C++, now of course you can't do end L in C, but you can do \n in both. When you do that, what it's doing is it's adding these two characters. And if you look at the ASCII table, one of these is the carriage return, and the other, or the line feed, and the other one is the go to the beginning of the line, carriage return. So you've got a line feed carriage return there, and notice how it is zero terminated. So it's a really good idea to do that as well. All right, so that's how you create characters or strings. These are characters, these are strings. Notice it doesn't matter if you use double quotes or single quotes. In any of these, I can put a single quote here in assembler, no problem. And I'm going to build to make sure I didn't tell you something wrong. There you go. Okay, what about arrays? So I can create an array of anything. And remember, it's all about size. It's not about data type. So I can say array 1, define byte. I can use a letter. I can put a number in there. I can put a hexadecimal number in there. It doesn't matter. What I've just created is I've created an array of 3 values. Now, I've never coded this way. This is one thing I don't like about Python, the Python language, is that you just can throw any kind of data into an array you want, which can be kind of confusing because, you know, some parts of an array you want to process as a number, some parts you want to process as a letter or a string. But you can do it here. I can create as many things as I want. I can even put a small string into this array. Now, what I've actually created here is I've created 3 bytes, 1 byte, and 1 byte. So this is an array that actually has 5 It's a size 5. So this is 5 bytes long. Because each one of these is a single character, each one of them is a byte. So that's how you can do that. Now you can also create another array. I could say define quads. So I can have quads in there. So each one of those will be 8 bytes long. So what's the length of that one? I've got 3 quads in there. Each quad is 8 bytes, so that's 24 bytes long. Or 3 quads. Okay, what if I want to create an uninitialized array? If I want to create an uninitialized array in Windows, what I can do is I can say array3. And in Linux, you would use the times, but in Windows, you use the dupe. So I'm going to say define byte. I want to say I want to define 10 bytes, and I want them to be duplicated with no initial value. So in array3, I say I want to define bytes 10 times, and I want them all to be duplicated with a question mark. And the question mark is uninitialized. So we're going to go ahead and rebuild this, make sure I didn't type anything bad. So I can create a very big array. I'm going to say define quads, 10,000 quads, and I don't want to initialize them to anything. Or I could initialize them all to 0, define quads, and let's say 50,000. I could initialize them to 0, or I could initialize them, let's do doubles. I could even put an H there. So all those will work. So the dupe says define 10,000 quads, and they're all uninitialized. So that's repeating values when you define an array. So we'll be talking more about arrays when we get into loops, maybe before that. And that's how you allocate variables inside of Windows, Visual Studio, Microsoft Assembler. Hope to see you at the next video.